Hello everyone, my name is Shubham Joshi and I am the team leader of Binary Based. And let us start with the problem statement itself. That problem statement is suggest a redefined solution to help cities locate electric vehicle charging infrastructure. So basically, in 5 to 10 years, India is going to develop in the electric vehicles. So definitely, the demand of electric vehicles will be more in the future. And basically, if electric vehicles are increasing on the road, we need a charging infrastructure. So the problem with the charging infrastructure is that we can't place it or we can't build it anywhere. We need to have some optimization with it, with the locations, because when there is a high demand, we should keep more charging station over there compared to the low demand area. So basically, our problem statement is revolving around this optimization problem, basically the demand and the supply problem. So our objective is to develop a sharing charging model. Now let me explain you about the sharing charging model. There can be a three ways of a charging model. The first one is public or sharing, and the second one is private, and the third one is the semi-public. So our focus is on the sharing charging model as given in the problem description. Okay, and our PS code is BV806, and Ministry of Housing and Urban Affairs are our ministry for this problem statement. Now let us go on to the solution which we have prepared. So basically, before going on to the solution, let me describe the technology stack. So basically, we have used in front end HTML, CSS, JavaScript, and React.js, and for the backend we have used Python and genetic algorithms, especially by PyGet. It is a library of Python uh, which is specially designed for the genetic algorithm only. So we are solving the problem, this optimization problem using genetic algorithm. So we have to use this, and some software used like QGIS and MATLAB. QGIS for geographic information system, so we need to analyze location, so we need this. And MATLAB is for mathematical function. We also need to optimize this with, there are many parameters including, so we have to use MATLAB. And the database which we are going to fetch is from the official governments and private websites to fetch the API database. The private ones are Ola, Ether, or Tata, which can provide us the database regarding the EVs, and the official government websites of the subsidies, so we can have a idea about the EV populations. So now let me describe the solution. So we have used the genetic algorithm for the optimization. So by geospatial analysis, that is using QGIS, we have found optimal location for the EV charging station. So basically we are going to put the solution on the map also, and we can also take the input from it, the map on itself. Next, we have derived a mathematical formulation. There are many parameters like demand and supply parameters, like the what is the population on the road that EV vehicles are there. So that is also there. The numbers, priority wise, we have decided the numbers also. And we have used the Python and PyGet Python library for the implementing genetic algorithm. Now let me explain you about the genetic algorithm. So basically, simple genetic algorithm where n is a initial population. So starting with, let me explain you the first n. What is initial population? Initial population is the number of locations, point, which can be a potential charging station in the future. Which can be a potential charging station in the future. So n is the initial population. Now let us start here. So create initial population. So we will basically create a initial population using QGIS and our data. So we can have a many points which is known as initial population. Now it will the algorithm will evaluate. We will create a function using NumPy and evaluate a fitness of each individual. So we will evaluate a fitness of each point. Now what is fitness? Fitness is a how much the point or that location is capable of making have a potential to become a future charging station for it, for the e-waste. So that is the fitness. So we will provide a fitness value to each and every location, or the each and every initial population. Now we will test it convergence, that is which we have the condition may be mathematical formulation. So optimization condition here which we are using is low or minimization. We are going to make a minimization of this mathematical formulation. So if every location has the same convergence, or that is a conditions, that is a minimization. So yeah, okay, we will return all the values with the best fitness values. So all are the best for it, and we will stop the algorithm. But if it is not the case, we will go to the if, from here. So select NP individuals. Now what is NP? NP is a suitable population, which is very less than initial population. This lesser population, that is NP, is a population which is having the high fitness compared to all the initial population. So these are having the very high fitness value, and we will create a mating pool randomly. That is, we will make this individuals, that is NP individuals, in a mating, that is we will make a pair of them, and we will generate a new offspring. That is, these are the parent individuals, we will pair them, and they will generate a new offspring, and that will be more fitter than the previous one. So reproducing or creating an offspring, we will use this thing, crossover and mutation. So crossover is again a function which will, there are 5 ways with the crossover. So we will produce some offspring using one of them, and we have a mutation. So we will also have a mutate those springs, and sorry, that parents, and we will generate a new offspring. So and then we will replace this new this new after the offspring generated. This is a new population, and we will replace with here, and again the fitness value will be assigned. Again convergence, if yes, then it will go and return those values and stop. Otherwise, again this iteration will continue. Now let us have a graphical uh, thought. These are the points that are initial population. So after optimization, we can get this. So these are the very optimized before optimization, after optimization using genetic algorithm. These are the potential points where the charging station can be made in future. Now, these points are not randomly fixed. Here, there are some public parkings. We have already decided where to keep this charging station. First one is the public parking. Then uh, so basically, this map is of Gandhinagar, Gujarat. So Gandhinagar is having a circle on a uh, every 2-3 kilometers. There is a circle. So that circle have a space. So we have used those space also for the charging. And street parking is the one of the option. And the fourth option is like a petrol pump, CNG, gas stations. So we can have the infrastructure ready-made in infrastructure. So we can have those electric charging station over there. So after doing this, we will get this. How? What is the parameter? Let me explain you first. Use cases. So these are basically parameters also. Maximization of accessibility. So accessibility is one of the parameter that the EV which are placed, which they are accessible to the public, because we are making for the public, right? So indicators can be visibility access of the major roads or local roads, or 24 into 7 access. That is day and night both, and for a week. That is, and then maximization of utilization, that it must be utilized according to the priority. Like if this area has a high priority, then it must have a 2, or if this area is a high priority, it must contain a 4 charging station, because there is a high demand over those areas. If there is a very less demand, then it might be 1. So this is the maximization of utilization. Indicators, that is the parameters like population, employment, density, traffic volumes, point of interest, and transit stations. Then again we have to discuss minimization of cost. Minimization of cost is, of course, we have done, because we have considered the inbuilt pre-built, sorry, infrastructure, that is petrol pump, public parking, and all those. So basically, and of course, a power supply connection also will be one of the parameter over there. And use cases, this government can use our approach for optimization of location to deploy the sharing charging models in the cities. Definitely. Now, let me describe some dependencies or showstoppers here. If invention of replaceable batteries happen in the future, so definitely this model can't work more. Yeah, it might work for a few, but it will not. Then privatization of EV charging stations. So what happened if the public or a person who owns a charging station, so it is a private, but he is allowing other persons to come and to get a charging from his charging station for some money. So no one will come to a public stations because they will be having large population in the for the charging line. So they will go for a private one. But there could be a solution that in our website we will not show the location of those private charging station. We will only show our public charging station location. So that can be also used. Okay, okay. Then we this charging EVs are time consuming definitely, and limited space of infrastructure. We are living in India, so definitely infrastructure is always a problem. But we have solved it because we are using petrol pumps and gas stations, which are pre-built infrastructure, and insufficient generation of power. That is also we have supply connection and all this. So basically, this was our idea, and let me move to the last end. So now let us discuss about the final product. So how platform will work? There will be two separate platform, one for the government and second for the public. So government platform, it is specially developed for the government authorities who can access to this software. So basically this software will provide location of best potential charging station as well as with the priority wise. We we can know the number of charging station required in that particular area. And second one will be public platform. It is developed especially for the public so that they can find where the charging station are located in the cities. These two platforms will be completely different, and government can access to public platform but public cannot access to the government platform, of course. And this public platform will provide the charging station suitable with respect to the current location of the customer. So this is how our final product will work, and it is on the parameters like area, traffic density, then land cost, infrastructure cost, investment cost. That priority can be decided with this too. Transportation cost towards the charging station's capacity, that how much the charging station has the capacity to charge, as well as electric grid capability. And that is a from where the power source, the final power source, that is from where the electricity will come into the charging station. This capability, we have to see this capacity also. So basically, these are the parameters which we have included in it. And okay, thank you. So ending part. This is our team and this is our mentor. And thank you for this. Thank you so much.